This time we're looking at section 4, which is about lines in the plane. We're going to be looking at the various types of equations of lines, the point-intercept, the point-slope form, the slope-intercept form, the general form. We'll also look at parallel and perpendicular lines, things like that. Once again, like the rest of the topics in this chapter, this should largely be review, but maybe there's something that you either didn't know or that you used to know but have since forgotten. So it's always important. So first up, our learning targets today. You can find the slope of a line. It's important. Find the equation of the line, point-slope form. Find the equation for a line, general form. And find the equation of the line, slope-intercept form. Those are the three main forms that we look at, and I'll talk about which one is important or which one is good for what purpose, because they all do have some different uses where they work better for. Then use graphing technology to graph lines. Graphing calculator, also Desmos. I'll show you that, how to use that in one of our meets. It's a really quick, you go to desmos.com, you click the graphing calculator button, and it takes you right there. So it's super easy, and a free app, so everybody has the access to it. So lines in the plane. First step, slope. What is slope? Slope is rise over run. It's the delta y over delta x. Delta is a Greek letter. We use it to mean change in. You may have seen it in science classes as well, but it's just the change in y over the change in x. And you get that by just subtracting. Remember to keep one of your points first and then the second point second. We can't switch the order because that changes the sign. So we are finding the slope. So if we have 2 points, let's say we have the point 5, 2 and the point 3, 7. To find the slope, we would go y minus y over x minus x. It does not matter which order we choose it in, we just have to be consistent. So we go slope m. Do you know why we use the variable m for slope? Nope, neither do I. I've looked it up. Nobody knows. They've had, there's some theories, but they've all kind of been disproven, so I don't know. So y minus y, we can go 2 minus 7 over 5 minus 3. Could have also done 7 minus 2 over 3 minus 5. Again, the order is what matters there. And then 2 minus 7 is negative 5. 5 minus 3 is 2. So we have negative 5 halves. Remember that negative 5 halves is the same as negative 5 over 2, which is the same as 5 over negative 2. Those are all equivalent statements. So you have negative 5 halves. That's how you find the slope. You've done that before. Point-slope form. The point-slope form of a line is y minus y1 equals the slope times x minus x1. Now, sometimes we take this minus y1 and we move it to the other side of the equal sign. So we have y equals y1 plus the slope times x minus x1. Having y equals is sometimes handy. When you're graphing stuff, y equals is how you have to graph it. So that is important. The point-slope form is super useful when we're writing the equation from the information that we have, such as what we just did. We know the slope is negative 5 halves, and we have 2 different points that we could use. So we just pick a point. We can have y minus 2 equals our slope, negative 5 halves, times x minus 5. There we go. That's the slope, the point-slope form of the line. Or in that second form, we could move that 2 over. So we have 2 minus 5 halves times x minus 5. So now it's in the y equals format of that. However, we could have also used the other point. we could have ended up with y equals 7 minus 5 halves times x minus 3. These two equations are the same. Like, they give us the equation for the same line, but they look different. So that can be problematic. We like things to be unique, where this line has this equation. And so that's what brings us to the slope-intercept form. The slope-intercept form is just that y equals mx plus b that we know and love. It's generally the first form that we really learn about. M is the slope, b is the y-intercept. To find this, I would start out with the point-slope form. You plug it into the point-slope form. We'll start with that equation. So I'm just going to bring it up. We know that y equals 2 minus 5 halves x minus 5. And then you simply just distribute and combine your like terms. Y equals 2 minus 5 halves x. And then when we distribute, that negative and negative gives us plus 25 halves. Combine our like terms. 2 could be rewritten as 4 halves. 4 halves plus 25 halves will be 29 halves. We have negative 5 halves x plus 29 halves. And that would be the slope-intercept form. Now, it doesn't matter which one of these two equations we started with, this would be the same, because this line has a y-intercept and it has a slope. And that's what this has. The other one relies on a point on the line, as opposed to this one, which relies specifically on the y-intercept. There's also the general form of the line. The general form looks like ax plus by equals c, or sometimes ax plus by plus c equals 0. And you might think like, wait, shouldn't we have to subtract the c over? Just two different ways of writing the equation. One of the c's would end up being a negative if we were looking at it from the equation part. So like these two c's are not the same. One of them would be negative of the other. But this is what it looks like. I've seen some that like some places like the top one, some places like the bottom one. You just have to be able to roll with it. So the point slope form uses really super good about writing the equation of a line from points and slopes. The slope-intercept form is the unique form of that, but it's also useful when we're doing like application problems that involve a rate of change and a starting value. The general form type problem are great for applications when we have things like you're selling hats for $2 a piece and shirts for $10 a piece, and you have to make $27. It's really easy to set those kinds of problems up using the general form. If we wanted to take our equation that we're working on and write it in the general form, it starts from the slope-intercept form. Like if I was given 2 points and had to write them in general form, I would first use point-slope form, take it to slope-intercept form, and then from there move it to general form. That's the easiest way of doing it. So to do that, I'm just going to rewrite so that we can actually see it, because it's a little bit covered up here. This y equals negative 5 halves x plus 29 halves. Very first step is multiply by the common denominator, which is 2 in this case. And so that gives us 2y equals negative 5x plus 29. We'd add the 5x over to get 5x plus 2y equals 29, or possibly 5x plus 2y minus 29 equals 0. Those are the two ways we could write it. Notice that we didn't just move the 29 over, we actually did subtract it. So if we were looking at the top equation, c would equal 29, but if we're looking at the bottom equation, c would equal negative 29. So that's just how you put it into general form. Graphing these, slope-intercept is easy to graph. That's where you start with graphing. You plot the intercept, use the slope. Point-slope form, you can start with whatever point you want, whatever point it gives you, and then use the slope. For general form, I would find the intercepts. If x equals 0, what will y equal? If y equals 0, what will x equal? We also have some horizontal lines. I'm going to erase this little piece right here. We've seen that. We don't need that anymore. So we have horizontal lines. Horizontal lines are of y equals b. Y always equals the exact same number no matter what x equals for a horizontal line. So if we wanted a horizontal line through the point 5, 2, it would be y equals 2 because we know that y equals 2. A vertical line is just x equals a number because x will always equal the number, doesn't matter what y equals. So a vertical line through the point 5, 2 is just x equals 5. Horizontal lines have a slope of 0. Vertical lines have a slope that is undefined because in our slope equation, we'd get something divided by 0, and so that's going to be undefined. An undefined slope just means it's vertical. If we're looking at parallel lines have the same slope. That's all parallel lines are. So if we wanted to find a line parallel to the one that we're working on, but it goes through the point 1, 5, that'll be okay. Make sure it wasn't actually on the same line. We would use the same slope, and this point 1, 5, we get y minus 2. Nope. Y minus 5 equals negative 5 halves. That's the same times x minus 1. We could make it slope-intercept, so we would distribute. So we have y minus 5 equals negative 5 halves x plus 5 halves. And then add the 5 over. 5 could also be called 10 halves. So we get y equals negative 5 halves x plus 15 halves. So the only part in a parallel line that would be different in slope-intercept form is that y-intercept. The other pieces would be the same. And finally, we have perpendicular lines. And perpendicular lines don't have the same slope, but the slopes are opposite reciprocals. So if our slope is negative 5 over 2, the perpendicular slope will be positive. We have to change the sign and then flip it. 2 over 5. So if we want the perpendicular line through this point 1, 5, we first we change the slope and then point slope form. Y minus 5 equals 2/5 times x minus 1. Distribute the 2/5. Y minus 5 equals 2/5 x minus 2/5. Add the 5 over. And 5 would be 25/5 minus 2/5 will be 23/5. So we have 2/5 x plus 23/5 would be the line perpendicular to this one that we were working with that goes through the point 1, 5. So that's the review of the different forms of line, different uses, different graphing, or different methods of graphing. So this is what you're working on for this section. I will see you in class. Until then, keep working problems, keep asking questions, and as always, happy mathing.